In this episode, let's investigate the performance implications of enabling encryption on Vexata's VX-100 Scalable Data System. This enterprise storage system secures your data using hardware-offloaded AES encryption at wire speed throughputs and a nearly immeasurable latency cost of only 1/10 of a microsecond. For performance characterization, we have set up 4 dual-socket Linux servers to act as hosts that access a VX100F NVMe flash storage system through a fiber channel SAN switch. A drive group is configured using RAID 5 redundancy, and let's initially leave encryption disabled to establish a baseline performance measurement. Before checking performance, we can take a peek behind the curtain and validate the encryption status inside the storage module. First, we need to associate the host-assigned disk ID back to a volume ID on the storage system, volume 110 in this case. Then, using a diagnostic tool on the storage system, let's look at the data stored in the first LBA of volume 110. The low-level diagnostic tool used here bypasses the hardware data path and decryption that an authenticated host read would use. Thus, the tool is showing us the data as it was written to the media in the storage module. Observe that the data in this first LBA is all zeros. Going back to the host, let's write a repeated hex string into the volume. In rereading the LBA at the storage system, we can see that the data has changed to the clear text version as written by the host. Running VDbench in parallel from 4 hosts using a fully random 8 KB I/O workload that is 80% read and 20% writes, observe the total throughput and IOPS of the unencrypted drive group. After deleting the previous drive group and cleaning up the disks on the attached hosts, now let's create a similar RAID 5 drive group, but this time with encryption enabled. Skipping past volume creation and host rescanning, here we have the storage system console at the top and a host console at the bottom. Associating the host's disk ID back to a volume ID and peeking at that volume's first LBA, we can see that the data is zeroed following creation. At the host, we again write the repeating hex pattern using DD. Peeking at the volume a second time, we see that it no longer shows the plaintext hex values written by the host. This is the post-encrypted data written to the flash on the storage module. Now let's check performance with encryption enabled using the same VDbench workload. As you can see, the throughput and IOPS remain unchanged from the unencrypted case. Additionally, there is no measurable impact on read or write latencies. In summary, Vexata's VX100 storage system will meet your regulatory requirements for securing sensitive data without compromising on record-setting application performance.